Good morning everyone. Today we are going to see about the second chapter, Classical Encryption Techniques in Cryptography and Network Security. So before starting this, we must know what do you mean by encryption and why you need this encryption techniques. So if a sender want to send the message securely through the internet in the receiver means you need some techniques to send your message securely. So in order to send your message securely, you will be using this encryption techniques. So next we will see about the introduction. So here you are having two types of encryption, symmetric encryption or asymmetric encryption. Symmetric encryption is nothing but here you will be using sharing a single key between the sender and the receiver. So how you will be sharing? You will be sharing it through a secured channel whom you trust more. So that is what the symmetric encryption is. Symmetric encryption is nothing but you will be encrypting. That is, you will be converting a original message to the secured message or the coded message using some algorithm and also using a single key. Single key means symmetric encryption. If you are using more than one keys, that is two keys, means that you will be calling it as a asymmetric encryption. So now we will see what are all the other names you are having for this symmetric encryption. You can call the symmetric encryption as a conventional encryption or a private key encryption or also a single key encryption. So as I told you earlier, here the sender and the receiver will be sharing a common key through some distributed channel. So all the encryption algorithms you are going to use here to secure your message will be using a single key or it will be using a private key. So this is the algorithm that is available prior to the public key in 1970s, and the symmetric encryption are widely used because here you are going to use only a single key. So some of the basic terms you must know before going in depth about what is a symmetric model and all. So the first thing you must know is plain text. The plain text is nothing but the original message you are going to send from the sender to the receiver. Ciphertext is nothing but the coded message or the message that is scrambled in such a way that the attacker will not be knowing about it. Okay. And this cipher is nothing but the algorithm you are going to use to transport or you are going to transform your plain text to a ciphertext. And the fourth term is key. The key is nothing but, as we have already seen, in this symmetric encryption you will be using a single key, that is a private key that will be used in that algorithm to transmit your or to convert your original message to a coded message. The next one is encryption, or you can call it as enciphering. It is nothing but converting the original message to the coded message. The next term is decryption or deciphering. It is nothing but converting back from the ciphertext to the plain text by the receiver end. This encryption will be performed at the sender end and the decryption will be performed at the receiver end. So next, what is cryptography? Cryptography is nothing but the study of encryption methods. The study of encryption methods is called as cryptography. Cryptanalysis or cryptanalysts are nothing but the code breakers who will be searching for number of methods to retrieve your ciphertext into to convert your ciphertext into a original text without even knowing the key. So these are all the code breakers, or you can call them as a crackers or hackers also. The next term is cryptology. Cryptology is nothing but it is a combination of both cryptography and cryptanalysis. Cryptography is the study of encryption methods and the cryptanalysis is the code breakers or the hackers who will be retrieving your information without knowing the key. So these are all some of the terms you must be familiar with before going in depth about the symmetric model. So this is what your the next slide you will be having the symmetric cipher model. Before that, these 5 steps will be performed in the symmetric cipher model. The first step is the plain text. What message you are going to send from the sender to the receiver, that will be given to that algorithm as an input. The second one is encryption algorithm. What type of encryption algorithm you are going to use. For example, you can use a DES or AES. That is, DES is nothing but data encryption standard, and AES is advanced encryption standard. These are all some of the algorithms you will be using in order to convert your plain text to a ciphertext. And in that algorithm, you must one key. That is what the third step. You will be using a secret key. That is the private key there. And in this encryption algorithm, you will be using number of substitution techniques and transformation techniques that we will see later. And the ciphertext, as you know, it is the scrambled or the coded message. And decryption algorithm will be used by the receiver to convert your ciphertext to a plain text, because the ciphertext will be in a scrambled one. The receiver will not be able to understand that. So you need to use a decryption algorithm in order to convert that scrambled message to the original message. So these are all the 5 steps. You will be using it in symmetric cipher model. So this is the diagram that depicts the symmetric cipher model. So initially you can see here you are giving the input as the x. X is nothing but your plain text that will be converted to a ciphertext. So after that x, your the second step is you will be using an encryption algorithm like AES and DES. In that algorithm, you will be using one secret key that will be shared between the sender and the receiver through some secured channel. Okay, so this key must be kept very secret. Otherwise, the attackers will be easily retrieving your information. So using that key in this encryption algorithm, you will be converting X to a ciphertext Y. So how you got that ciphertext Y? So Y equal to E of K comma X. It is nothing but E is the encryption algorithm, K is the private key you are using here, and X is the plain text. So how you will be getting this ciphertext Y? If you apply encryption using the key K on the plain text X, then you will be getting your ciphertext Y. So this ciphertext Y will be reaching the receiver end. So what the receiver end will be doing? Again, he will be using a decryption algorithm. So in that algorithm, that receiver will be using the same key that is used by the sender, and using that decryption algorithm, he will be converting that ciphertext to a original message. So what happens here? What happens here is the encrypted text will be sent securely through the secured channel to the receiver end. So this is what your symmetric cipher model, where the plain text will be converted to a cipher text. So this is what symmetric cipher model. So here you need 2 main requirements in order to send the message securely. So the first one is you need a strong encryption algorithm like DES and AES. And also the key you are going to use in that algorithm must be kept secret. So mathematically you can express this X and Y. X is a plain text and Y is a ciphertext. So how you got your ciphertext? By encrypting and plain text using the key K, you will be getting the ciphertext Y. Similarly, how you got that plain text X at the receiver end? By applying the decryption algorithm on the ciphertext Y using the key K, you will be getting your plain text back. That is, the original message will be received by the receiver. So the sender will be sending the plain text, it will be converted to the ciphertext Y, and again at the receiver end you will be using a decryption algorithm to get the original message back. So this is what about your symmetric cipher model. So the next one is cryptography. Cryptography is nothing but the study of different methods. So how the characterization is done here in this cryptographic system is there are 3 types of characterization based upon, the first one is based upon the type of encryption operation you are going to use. That is, either you can use substitution techniques, or you can use transposition techniques, or you can use a product of both this substitution and transposition. Substitution is nothing but for one letter you will be substituting another letter. In that way you will be performing those operations that we will see later. Transposition is nothing but you will be changing the position of that particular letter instead of changing that letter itself. So this is what about the first characterization. Second characterization will be based upon the number of keys you are using. As I told you, in the symmetric encryption you will be using a single key or a private key. So if you are using a single or private key, depending upon that characterization also you can differentiate those cryptographic system. The other thing is you can use either two keys, or you can call it as a public key or a asymmetric key encryption. So these are all depending upon the keys you are using, you can characterize them. The third one is the way in which the plain text is processed. That is how you are going to process the plain text. Block by block means you are going to separate those plain text into a block of messages, and then you are going to transmit, or you are going to send those messages bit by bit. Bit by bit sending is called a stream. Or if you are going to send a block, that is, block is nothing but the part of a message will be sent first, will be converted first, next the second block will be executed. Likewise it continues. So now we will see about the transposition ciphers. As I told you, transposition is nothing but just you will be rearranging the letter order. You will not be substituting some letters for the original letters, just you will be rearranging the position. So here you are having two types in this transposition ciphers. The one is Raylfen Cipher and the next one is row transposition cipher. We will see one by one all those things. So in this Raylfen Cipher, you will be writing all the letters in a diagonal manner. For example, the original message you are going to transmit from the sender to the receiver is meet me after the Togo party. Okay, you can write those messages in a diagonal manner, like M in the first row. In the second row diagonally you can write E, and then again in the first row you will be writing E. The second row T, meet me. Next M, E, A, F, T, E, R. Likewise you will be writing all the letters in a diagonal manner. Using two rows you are separating it. First letter in the first row, second letter diagonally in the second row. Third letter again in the first row, fourth letter in the second row, fifth letter in the first row, and sixth letter in the second row. Likewise you will be writing all those values, and finally you will be getting the ciphertext by reading the first row first and the second row next. For example, in our example you will be writing the ciphertext as M-E M-A-T-R-H-T-G-P-R-Y. This is the first row. After that, continuously you will be writing the second row, that is E-T-E-F-E-T-E-O-A-A-T. This is what is called as Raylfen Cipher. You will be writing it in a rail manner, diagonally, one after the other. Meet means you will be writing M in the first row, E in the second row, the third letter E in the first row, and the fourth letter T in the second row. When reading it, you will be writing it as M-E-E-T. Okay, likewise it will be converted. So the second type is row transposition cipher. It is a somewhat complex transposition compared to your Raylfens. So here what you will be doing is you will be writing that plain text in a rows in a specified number of columns. For example, the key you are going to use is 4312567. This is the key you are going to use. So what happens? So how many how many digits you are having here? 7 digits. So you will be writing that plain text in 7 rows, like 7 columns, like 8. The message you are going to transfer from the sender to the receiver is attack postponed until 2 a.m. Okay, this is the message you are going to transfer from the sender to the receiver. So how you will be writing? You will be filling the first 7 letters, then the second 7 letters in the second row, third 7 letters in the remaining row, and the last row, whatever the empty space you are having, like in our example 2 a.m. After that a.m. you are having XYZ. That XYZs are nothing but the fillers. You can fill those empty spaces with some other random words. Okay, most oftenly that last words, if you are using it, it will be easy. So that is what X, Y and Z. So after writing this, you will be taking the number 1. Where is number 1 in the key? That is that particular column you will be writing it first. So 4, 3, 1. The third column is the third digit is 1. So in that 1 column, what are all the letters you are having? T, T, N, A. T, T, N, A. So that you will be writing it first. Where is the second number? The second number is at the 4th place. So again you will be writing it as A, P, T, M. Likewise you will be proceeding. Next comes the third column, then the 4th column, 5th column, 6th column and finally the 7th column. All those things you will be writing it in a single line. So this is what called as a row transposition cipher. You are transpositioning, that is only the position of that particular letters have been changed. Okay, so this is what your row transposition cipher. This is a single stage row transposition. If you want to go to the second stage means, again you can use a different key here. So in the previous slide we have seen about the key we have used is something different, 4, 2, 1, 3, 6, 7. So here we are using a different key like 2, 1, 4, 3, 5, 6, 7. So again, whatever ciphertext you have got in the previous slide, you will be writing it in the 7 columns one by one, and here you will not be using the fillers because it will be having the correct number of letters. So now you will fetch the first column, that is N, S, C, Y. Okay, next the number 2, where the column 2 is there, it is at the fourth column. So again you will be writing it as A, U, O, P. Likewise it goes on. Likewise you can go for third stage of transposition. Likewise, if you are using more than one stage of transposition, it will be very complex or very difficult for the attackers to retrieve it. Okay, now we have finished the transposition techniques. Next we will see about the substitution techniques. So in this substitution we will just go through about this 3 techniques: Caesar cipher, monoalphabetic cipher and Playfair cipher today. We will see the remaining things in the next video. So first we will see about the Caesar cipher. This is the earliest or the first substitution cipher. It is named after the inventor Julius Caesar. He will be using the Caesar cipher in the military affairs, that is replacing each letter by the third letter. For example, take the same example, meet me after the Togo party. This is the plain text you are going to send from the sender to the receiver. So the third letter from M is P. So therefore you will be replacing M by P. After E, the third letter is H. So E will be replaced by H. Similarly, the second E will also be replaced by H, and the T. In the meet you are having the letter as T. From T, the third letter is W. T, U, V, W. So W will be replaced here. Similarly, it will be proceeding on until the plain text. I hope you have understood. I will repeat again. You will be fetching the third letter from the original text. After M, N, O, P. P is the third letter. So you will be replacing M by P. After E, F, G, H. So H is the third letter. So you will be replacing 2 E's by 2 H. And after that T, the third letter is W. So you will be replacing T by W. Likewise, it proceeds on. So this is what your Caesar cipher. So in order to use it easily, you can write first all the alphabets from A to Z, and you can replace that with the third letter. Then it will be easy for you to replace all the letters, whatever the letter you are using. It need not be the third letter. You can replace that with the fifth letter also. Accordingly, the key value will be changed. Okay, so how you got the ciphertext? By using plain text plus key is 3 or 5. How many letters you are going to add from that. So that is k value mod 26. 26 is the total number of alphabets you are having in English. So 26. So similarly, how you got the plain text? By applying the decryption on the ciphertext C. So in that, what you will be doing? You will be subtracting those many letters from the ciphertext. That is, if you have added 3 numbers, means you will be subtracting 3 numbers in order to get the plain text. So this is about your Caesar cipher. The next technique is your monoalphabetic cipher. Here it is nothing but just you will be randomly substituting one letter for another letter. So like for A you are substituting D. There will not be any relation between the plain text and the ciphertext, and Z is replaced by N. Randomly you will be choosing one letter and you will be substituting it for the plain letter. Whereas in Caesar cipher you will be having one order. Like for this particular letter you will be having adding 3 letters or adding 5 letters. That is not there in the monoalphabetic cipher. Randomly you will be selecting some letters and you will be substituting it. So first you will be writing the plain text and the ciphertext randomly by choosing the letters, and after that if you want to convert it, like if we wish to replace letter is the plain text, you are going to send from the sender to the receiver. Then looking into the previous ciphertext, you will be replacing it and you will be converting it into a ciphertext. So the last technique we are going to see here is Playfair Cipher. So this Playfair Cipher is having the very good security compared to your Caesar cipher and monoalphabetic cipher. This is invented by this Charles Wheatstone in the year 1854, and it is named after his very best friend Baron Playfair. This is an introduction about your Playfair cipher. So here you will be choosing a 5x5 matrix depending upon the keyword you are using. So you will be filling in the keywords. In this example, that is in the table given below, monarchy is the keyword I have chosen. So in this monarchy, MONARCHY. After that you will be filling the remaining matrix because we have taken a 5x5 matrix. The remaining letters will be filled in such a way there will not be any duplicates in the keyword itself. Okay, I will explain you in detail. So the first letter is A. A is there in the keyword monarchy. So you will be leaving that alphabet A. The next alphabet is B. In B, whether it is available in the keyword monarchy? No. So you can write that B. C is there in the monarchy, so you will be leaving it. D, it is not there, so you will be including it after D. So how you will be filling the next row? Similarly, after D, you will be having E, it is not in the keyword, so you will be writing it. F, it is not in the keyword. G, not in the keyword. I and J. I and J will be sharing the same cell. That is the rule there. If that I or J is there in the monarchy, that is in the keyword, means there also it will be sharing the same cells. Okay, because 5x5 means you will be having only 25 cells, but we are having 26 alphabets. So I and J will be sharing the same cells. So likewise you will be filling the remaining matrix also. So here you will be taking the plain text as you will be taking the plain text as a 2 letters. So pair of letters will be taken. For example, assume you are having the plain text as balloon. First separate them into 2 letters. BA as one letter, LL. The next 2 letters are repeated. If the letters are repeated, you can use certain fillers like X or Y or Z. So in this example, I have used X as the filler. So LX, then LO, and then ON. So likewise, the first step in this Playfair matrices, I have to separate them into 2 pair of letters. In case if there is any repeated letters, I will be separating them with the fillers. Okay. The second step is, if both the letters are in the same row, replace each by the right of that letters. For example, so in this matrix you are having AR. So here you are having A and R. Can you see in the first row you are having the letters A and R? Okay. If you are having the plain text as AR, it will be replaced by M and O, because after R it will go in a circular way. So AR will be replaced by R and M, because the next letter to A is R and the next letter to R is M. AR will be replaced by R and M, that you can see here. I hope you have understood the second point. The second point is, if both the letters comes in the same row, means you will be taking the letters that are to the right of those letters. For example, in this matrix, NA means you will be replacing NA by AR. Okay. If you are having Q and S means you will be replacing it by S and T. If you are having FG means you can replace it by GI or GJ. All are same. So the third step is, if both the letters fall in the same column, then you have to replace it by the below letter. For example, if you are having M and C falls in the same row, you will be replacing it by C and E. If you are having H and F, you will be replacing it by F and P. If you are having K and T, you will be replacing it by T and Z. If you are having BI, you will be replacing it by JS or IS. Okay. So this is the third step in the column. If the two letters you are separating in the first step comes in the same column, you will be replacing it by the next letters. So what is your fourth step? Each letter is replaced by the letter in the same row and in the column of the other letter of the pair. For example, HS. Take the letter H and S. Where is H? H is in the second row, second column. S is in the fourth row, fourth column. So how you will be replacing this H and S? Take H and S, that will be considered as one matrix, and H is coincides at B. Come straight to the H. Next to H you are having this B, where this H and S coordinates at B and P. Okay. So H coordinates at B and S coordinates at P. So B and P are the encrypted or the ciphertext of this value H and S. You have to take it diagonally. For example, take it as O and S. Okay. O and S, where it coordinates A and P. A and P are the ciphertext. Likewise it goes on. So decryption will work exactly in the reverse order. Okay. So one more example we can see here. EA. Where is E? E is at the third row, first word. A. Where is A? A is at the first row, fourth item. So EA. What will be the answer? IM or JM. So this is what about your Playfair key matrix. So these are all the different techniques we have seen today. The first we have seen about the introduction. Next, what is an symmetric cipher model. Then we have seen about the characterization in the encryption. Then we have seen about the substitution and transposition techniques. In the transposition, we have seen two techniques, Raylfen and row transposition cipher. And in the substitution techniques, we have seen the three things, Caesar cipher, monoalphabetic cipher and the Playfair key matrix. Okay, that's all for today's video. We will meet in the next one. Thank you.